Hello there and welcome back. My name is Michael Fudge and this is lesson 4 in our series on learning to program in Java. In this lesson we'll cover classes, objects, and class libraries. We're not going to focus on creating classes, but using existing classes and declaring objects. Lesson 5 will discuss creating classes in detail. Our agenda for today will be to discuss the object and class concept. We'll talk about how objects get constructed from a class, and then we'll get into some examples, and along the way we'll use packages and libraries. And the 3 libraries that we'll use are the math library, the random library, and string builder. First, let's talk about some concepts before we get into the code. There's the notion of an object, and then there's a class. Objects are like variables, but they contain not only state, like a traditional variable would have, but also behaviors, that is, actions associated with the object. The best metaphor for an object is to think about something in the real world, like a bike. A bike might have wheels, and it might have gears and pedals. These are all parts of the object, and it might have behaviors like shifting from one gear to the next, or applying the brakes. In Java, state is represented as a property, and behaviors are represented as methods. So you'll hear me say the word method. When I say the word method, I'm referring to a behavior on an object. When I say properties, I'm referring to the characteristic of that object. Now, a class is a blueprint or a definition for an object. The way I like to think of a class is like building a custom data type, and the variables that you declare from that class are objects. That's the best way to think about it. All dogs have these characteristics. States like what color is the dog's fur, or how long is their fur, and do they shed their fur. And dogs have behaviors. They bark, they eat a kind of food, and their tails wag at a certain rate. Those characteristics, as they're generally defined, represent the class of all dogs. Every dog has these characteristics. How long the particular dog's fur is, or what color the fur is, or whether or not they shed their fur, that's particular to the actual dog itself. Those are represented as objects. So as you can see, you get a lot of variability out of your objects from the base class. Here's an example of how the objects and the classes relate together with something that you're familiar with, the scanner class. Remember, we use the scanner class to get input from the user when the program executes. So let's break down this statement in more details. If you remember from earlier lessons, I said just take this statement on blind faith and we'll discuss it later. Now is that time where we're discussing it later. Scanner is the class. This is the template for the object. Input is the name of the object. So when we say scanner input, we could say scanner X or scanner Y. It doesn't have to be input. We're just giving it a name that's conducive to what the object is going to do. It's going to accept input. But what's important is that the object input is of type scanner, and because it's of type scanner, it's going to have specific behaviors and state. Automatically, it's going to inherit these properties and methods associated with the fact that it is a scanner. The equal sign, you know what that does. That assigns a value to a variable. In this case, it's going to assign a value to an object. And objects are not like variables in that you have to construct the object, and the object is always constructed the same way, with the new keyword, and then you represent the class of the object, and you pass in 0 or more constructor arguments. The arguments that go into the constructor depend on how the constructor is defined, which in turn defines how the object should be created from the class. Alright, enough theory. Let's get down and write some code. And we'll use 3 examples. We'll do one with random numbers, another one that demonstrates how you can reverse the characters in a string, and then a final one using some math. Oh joy. What I will mention about all of these examples, we're going to use classes that already exist in the Java class library. We're going to import packages that are part of the standard Java developers kit and use the classes that are in those packages to make our objects. And this is one of the powerful characteristics of object-oriented programming, is that you can reuse other people's code so that you don't have to start from scratch and invent the wheel all over again. Let's get started. Okay, I have my NetBeans IDE up and running, and I created a new project called Random Example, and I'm now in the main method inside the Random Example Java class, and I'm going to write some code here to get a random number between 0 and 9 and print it out. And of course, you might be saying to yourself, why, Mike, did you put the word pseudo-random there and not random? Well, believe it or not, truly randomizing numbers with a computer is a very, very difficult problem in computer science. And when you think about what a computer is, it's a machine that has very specific rules and instructions built into it. And when you think about what randomness is, it's pretty darn random. It's hard to create a system that is truly random on a computer, which is, like I said, a finite machine with a specific set of instructions. There's lots of techniques that can be used to generate random numbers, but this is a big problem, and there's some interesting science that goes into generating truly random numbers for computers. We'll use the random number generator that's built into the Java class library in the Java Developers Kit. And this random generator is kind of interesting because you can seed it. And when you seed a random generator, it will always, if you give it a specific seed, it will always generate out the same sequence. And you might say, well, isn't that kind of silly? Why would I want to do that? But the advantages of that is that you can then test or replay a given scenario. Imagine you're making a game, and you want to always guarantee that the game outcome will be the same because you're trying to test the game. One way you can guarantee that would be to seed the random number generator of that game with the same number every time you play it. Then you should expect to get the same outcomes. All right, enough of the talk. Let's get into it. So I want to make an object of type random, and I'm going to call it generator. And I'm going to create a new object of type random. And you'll see that this generates an error because it doesn't know what random is. I need to import the package from the JDK that contains the class random. And again, the best way to do that is to press Control-Shift-I. And that will automatically figure out the import that I need from the JDK to include which package I need to include into my example in order to make this, in order to find this class. I just said new random, and I didn't specify a seed. I think what I'm going to do right now is I'm going to put a seed number in here, put in 1 for my seed. Now continuing on with my example, I'm going to do int I, and I'm going to set that to generator.nextInt 10. And that's going to get me a random number between 0 and 9. And then let's print it out. And for good measure, let's repeat lines 10 and 11 2 more times. You know, obviously I can't declare the variable, so I've already declared it once. Looks good. Let's run our program, F6. And my output is 587. Now, because I've seeded this random number generator with the same value, every time I run it, I will get the same set of random numbers. That's not very random, is it? But like I said, if you're trying to test your program, when you need to test your code, you need predictability. When you're playing a game, you need unpredictability, right? So by seeding the random generator, I can always guarantee I'll get the same numbers. For example, if I use 10 and run it, I'll get a different sequence. But every time I run it, I'm running it, I'm running it, I'm running it, I get the same sequence. So you might say, well, Mike, what if I want to get a truly random sequence, or the best pseudo-random sequence I can get? If you leave off a seed on random, it will pick a random number in which to seed the random generator. Usually the random number that it picks is based on the current system time. So let me run this. I get a random sequence of integers, 992, then I run it again. I get 665, I run it again. I get 316. Run it again, I get 296. And now I get 315. Okay, so you see how that works. At this point, you might be asking yourself, well, hey, Mike, how did you figure this out? You know, are you going to teach me to fish here or not? And the answer, of course, is yes. When you discover a new class and you want to figure out how to use that class, like for example, how did I know that there was a nextInt method on the random class, and how did I know that 10 would give it a value between 1 and 9? Let me explain how you do that. The way you do that is you look at the JavaDocs. So for any class, you can bring up the JavaDocs, and for any method, you can bring up the JavaDocs. The way you do that in NetBeans is you just highlight the thing you want information on, and then you press Alt F1, or I'm going to just right-click and hit Show JavaDoc. That's going to open up in a browser, and you can see public random creates a new random number generator. This constructor sets the seed of the random number generator to a likely value to be distinct from any other invocation of the constructor. And then you can also pass in a seed. Creates a random number generator using long seed, which is the same as doing this code here. So the instructions for how to use the class are usually embedded into the JavaDocs. In another lesson, maybe I think it's Lesson 7, we'll learn how to create our own JavaDocs for the classes that we make. And this is always a good idea, so that the classes that you make, you're not going to remember all the code that you write. So the idea is that you can go back and look at your own documentation. Well, let's find nextInt. NextInt returns the next pseudo-random uniformly distributed int. NextInt with a number returns a pseudo-random distributed int between 0 and the specified value exclusive. So if I say nextInt 10, it will give me a value between 0 and 9. So that's how I knew how to use nextInt, was I simply read the JavaDoc. Okay, I've already primed up our next example, and the goal of this example is to take the string forward, which says this is a test, and print out the exact same string but in reverse, whatever that would be. That was a bad joke. I did a little research on how to do this, and the best way to accomplish this is with the string builder class. String builder, SB, assign new string builder. Before I knew how to do this, once I determined I'd need string builder, I inspected the JavaDocs. So let's take a peek. So at the top of this JavaDoc, it tells you what the string builder class is, and then it gives you a basic definition and defines what it's for and how it works. And then there's a summary of how the constructor works, and then a summary of the methods. Appends the string representation to the sequence. And then if you look down further in string builder, you'll see that there's also a reverse, causes the character sequence to be replaced by the reverse of the sequence. So I think I have enough tools here to figure out how to do this now that I've inspected the JavaDocs. If I want to see exactly how to use reverse, I can click here, and then it takes me in here and discusses it in more detail. But I think I could try to figure this out. So the first thing I need to do is put my forward string in the string builder. So I'm going to do that now, SB dot. When I hit the dot on SB, which is an object of type string builder, the dot is an operator that references the properties and methods of the class of the object. So you immediately see all the append methods in here, and if I look hard enough, I'll see the reverse method in here. So that's another way that the JavaDocs are exposed as you type. I'm going to type in append, and I want to append the forward string. Now what I want to do is I want to make another string called reverse, and I want to set that to string builder dot reverse. Now when I type in this statement, you can see that there's an error, and it says incompatible types. I'm looking for a string, but I found a string builder. If you look at the JavaDocs on reverse, you can find out why this is. If I go to show JavaDoc, it says that the reverse method returns a string builder. It does not return a string. So reverses the string builder, and then I need to take that string builder and convert it to a string using the toString method. So what's neat about objects is you could just chain them together with the dot command, right? So SB reverse and then dot toString. So let me kind of explain this in a little more detail. This is a string builder. This references a property or method of that string builder class called reverse. Reverse, when it's done doing its business, returns back another string builder, and that string builder, I'm referencing that method of it named toString, which in turn returns a string, and then I'm taking that string and assigning it to reverse. Whew. Let's print them out and see if it works. And a little F6 to execute. This is a test. So it looks like it worked. Cool. If line 10 sort of freaks you out, I can break it up into a couple of statements so that you can see what's really going on better. What if I wrote it like this? What if I said string builder, on line 10 I said string builder reverse SB and assign to that my existing string builder dot reverse. Then on line 11 I say take my reverse string builder and convert it to a string. When I run this, I should get the same results. And I do. You might be wondering, well, why didn't I have to use new when I declared reverse SB of type string builder here? That's because I'm using the existing object that's being returned from the reverse method of string builder. I don't need to create a new object. You only need the new keyword when you're declaring a new object of that class, which I'm not doing here. Okay, let's move on to our last example. In this last example, I've started by writing a little bit of code already. This code in line 9 creates an input object of type scanner class. Then it prompts me to enter the radius of a circle and then uses the input object to retrieve a double from the user. So if I run this really quick, you can see that this will ask me to enter the circle's radius, and I can put in 2.5 as the radius, and then the program's over. What I'd like to do at this point is calculate the circumference and the area of a circle with that radius. Now, I know this isn't math class, and you might be a little rusty, but the circumference of a circle would be 2 times pi times the radius. Now, I know what pi is, but that's because I'm a wicked nerd. You might not know or remember what the value of pi is, and this is where our last example comes in using the math library. The math library has a property in it called pi, which will retrieve whatever the value of pi is, which is always the same thing. Pi is the ratio of a diameter of a circle to its circumference. So what I want to do is say double circ and assign that to 2 and then math dot pi. You can see the double value that is closer to any other to pi, the ratio of the circumference to the circle's diameter. Boy, I look smart, don't I? And then let's also, while we're at it, calculate the area of the circle. Why not? Double area, and the area is math dot pi times radius times radius. And then let's print them out. So this printf takes 2 arguments, circumference, area. So I'll pass in circ and area. Now you might say, this is a silly example, Mike, because I could have just went up here and said double pi, assign the value 3.1415927. I could have done something like that. Told you I'm a nerd. But the advantage of using the class library is, again, you don't have to reinvent the wheel. I don't ever have to remember what pi is. When you get as old as me, you remember one thing and then you forget something else. So when your brain's one in, one out, it's much easier to remember where to find things than to remember what they are. Let's run the program. Enter circle's radius. Let's enter 2.5. Circumference 15.7. Area 19.63. Well, that concludes our lesson 4, a gentle introduction to objects, classes, and packages in Java. Next week, we'll learn to create our own classes and then use those in our own Java programs. It should get interesting. Again, thank you very much for watching. If you have any questions, comments, or just would like to post some feedback, please do so on my YouTube channel. Thank you. Bye.